Bismillahirrahmanirrahim. My name is Israr Khan. I am a lecturer at Institute of Numerical Sciences, Quadratic University. And today I am going to deliver a lecture on mathematics PSY-102. Our today's topic is quadratic equations. These are the outlines for my today's lecture. Quadratic equation. We know that the general form of quadratic equation is ax square plus bx plus c is equal to 0. And this equation a, b and c are constant, and there is a condition that a is not equal to 0. If we put a is equal to 0, then this equation becomes a linear equation. Now we are moving to the solution of quadratic equation. Here we are going to discuss only two methods to solve the quadratic equation. One is factorization and the other is quadratic formula. Now here is the first example. We have to solve this by factorization. X square minus 9x plus 14. Now the procedure to solve a quadratic equation by factorization is we multiply these two, the coefficient of this multiply by this, then this becomes 14. Then we find the multiplicating factor of 14, and we only pick those multiplicating factor of 14, the addition or subtraction, which gives us minus 9. The multiplicating factor of 14 is 1 and 14, but neither addition nor subtraction give us 9. The other multiplicating factors of 14 is minus 7 and minus 2. When we multiply minus 7 and minus 2, it gives us plus 14, and when we add minus 7 and minus 2, it gives us minus 9. So here we replace minus 9x by minus 7x minus 2x. When we add these two, it gives us minus 9x. When we multiply these two, it gives us 14x square. Now we can see there are four terms. We make two couples. From these two we get x common, and here we are left with x minus 7, and from here we get minus 2 common, and here again we left with x minus 7. And these two terms we can see that x minus 7 is common, so we take x minus 7 common and we are left with x minus 2. When the product of two terms is equal to 0, we can equate them to 0. We can separately equate them to 0. Mean x minus 7 is equal to 0 and x minus 2 is equal to 0. So from here we get x equal to 7 from here, and from this one x equal to 2. So x is equal to 2 and 7 is the solution of the quadratic equation given here. We can check this solution by putting the value of x. Suppose we get this solution, we put this in place of x, so this equal 2 square minus 9 multiplied by 2 plus 14, and this is 18 minus 18 is equal to 0. This satisfies our equation, so it means this is the solution of the given quadratic equation. We can verify this equation for x equal to 7 as well. And now this is another quadratic equation. We have to solve this by quadratic formula. The equation is x square minus 5x plus 6 equal to 0. And we know the quadratic formula is x equal to minus b plus minus under b square minus 4ac under the root divided by 2a. If we compare this equation with the general form of quadratic equation, which is ax square plus bx plus c, we get a is equal to 1, b is equal to minus 5 and c is equal to 6. Now we plug these values in the quadratic formula. X equal to minus and minus 5 plus minus 5 square minus 4, 1 and 6 divided by 2a. So x equal to 5 plus minus 25 minus 4 divided by this, and x equal to 5 plus minus 1 divided by 2. Now we take these two separately, means x is equal to either 5 plus 1 divided by 2 or 5 minus 1 divided by 2. From this we get 6 divided by 2, that is equal to 3, and from this we get 5 minus 1 divided by 2 is equal to 4. We can also verify these two values the way we did in the previous question. Now here is the third example. We are discussing a word problem. The length of a rectangle is 5 cm more than its width, and the area is 50 cm square. Find the length, width, and the perimeter. We have a rectangle the length of this rectangle is 5 cm more than its width, and its area is given as 50 cm square. All we have to do is to find the length, width, and the perimeter of this rectangle. Suppose x is the width, and we know that the length is 5 cm more than the width, so the length is x plus 5. Now this is the width and this is the length, and we know that the area of a rectangle is length multiplied by its width. So length is x, and so length is x plus 5 and width is x, and the area we are already given, that is 50. So x into x plus 5 is equal to 50, and when we multiply this it becomes a quadratic equation. X square plus 5x minus 50 is equal to 0. We can solve it either by quadratic formula or factorization. Here we are using the factorization technique. So we find the two multiplicating factor of 50, that is 10 and 5, the subtraction of which gives us 5. So the method we discussed in the previous slide, we make two couples here of these four terms. From this thing we get x common, and from this we take 5, and x plus 10 into x minus 5 is equal to 0. We equate them separately to 0, and from here we get x minus 10 and x is equal to 5. X minus 10 is not possible, length can never be negative, so we take x equal to 5, which is the width, and to find the length we add 5, so 5 plus 5 is equal to 10. It means 10 is the length, 5 is the width, and we know the perimeter of the rectangle is the addition of all the four sides. 10 plus 5 15 plus 10 25, and plus 5 30. So the perimeter of this rectangle is 30 centimeters. Now there's another problem relating the quadratic equation. The three sides of our right triangle are x, x plus 1 and 5. Find x and the area if the longest side is 5. Here we are given with this information that we have a right triangle in which there are three sides. One is x, the other one is x plus 1, and the next one is 5. We have to find x, the area of the triangle, and the if the longest side is 5. We know that in a right triangle the hypotenuse is always the longest side, and by using Pythagoras theorem we know that x square plus x plus 1 whole square is equal to 5 square. Mean the sum of the square of the other two sides is equal to the longest side, which by after some simplification give us this quadratic equation 2x square plus 2x minus 24, and when we divide every term by 2, we get x square plus x minus 2, which after factorization give us two factors, x minus 3 and x plus 4. We equate them to 0 separately. We get x equal to minus 4, which is not possible because we know that length can never be negative, and we take x equal to 3. So the smallest side is 3, the other side is x plus 1, so 3 plus 1 is equal to 4. So one side is 3, the other is 4. Now to find the area, we know that area of a right triangle is equal to half height and multiply by base. So 1 over 2, 3 multiplied by 4, that is equal to 6 centimeters square. So the area of this triangle, whose longest side mean the hypotenuse is 5, and the other two sides are 3 and 4 respectively. Now here's a fifth example. The product of the men's age 5 years ago and 5 years later is 600. Find the present age. This problem is about the men's age. The product of the men's age 5 years ago and 5 years later is 600, and we have to find its present age. Age of a man is 5 years ago, so suppose x is the present age of the man. So 5 years ago its age was x minus 5, and 5 years later its age will be x plus 5. If we multiply these two, we get 600 as per the condition given in the question. X minus 5, x plus 5 is equal to x square minus 25 is equal to 600, and we get x square is equal to 625. When we take square root, we get x is equal to plus minus 25. Minus 25 is not possible, so x is equal to, we take x equal to 25. So the present age of a man of the men is, so the present age of the men will be 25. And now here's another example. The difference of two numbers is 24, and their product is 224. Find the number. Let x and y be the number whose difference is 2, mean x minus y is equal to 2, and whose product is 24, mean x multiplied by y is equal to 24. From x minus y is equal to 2, we get x equal to y plus 2, and we plugged the value of this x and this xy is equal to 224. So we get a quadratic equation in y, that is y square plus 2y minus 224. By factorization, it gives us two factors, y plus 16 and y minus 14 is equal to 0. So y can either be minus 16. If we put y is equal to minus 16, then x is equal to minus 16 plus 2 minus 14. If we take y is equal to 14, then x is equal to 16. So we have two pairs of solution. X, y can either be minus 14, 16 or 16, 14. These both solutions satisfy the condition given in the question, mean their difference will give us 2 and their product will give us 224. That's all. Thank you very much.